Okay, this is a continuation of lesson 7.2. This is about the washer method. So we had the disk method already, which was having the volume of a shape that's a function being revolved around an axis with there's no holes in the middle. Now the difference between that and the washer is that with the washer there's always going to be a space in the middle. As you can see, there's a smaller r. So there's going to be a top capital R and a bottom a little r, and there it makes sense that it's called the washer because there's a hole in it, and when this is being revolved around an axis, it's going to look like a washer. Okay, so let's do an example of this. So we're going to find the volume of a solid formed by revolving the region bounded by the graphs of the square root of x and x squared. So x squared looks like that, and square root of x looks like that. So this is x squared, this is the square root of x, and this is our region between them, and we are revolving this about the x-axis. Okay, so we need to figure out what our capital R of x is, which one is on top, and our little r of x, which is on the bottom. So pretty much you have to think about which one is farther away from the axis of revolution, and our capital R is clearly going to be the square root of x, and our little r is going to be x squared. So the formula, as we can see up above, is capital R squared minus little r squared, and times pi on the outside still. So we are revolving from 0 to 1, which is where they intersect. Capital R squared is the square root of x, quantity squared, minus little r squared, which is x squared, quantity squared, dx, pi from 0 to 1 of x minus x to the fourth, pi times x squared over 2 minus x to the fifth over 5, evaluated from 0 to 1, which gives us 3 pi over 10. Now, the three-dimensional objects I am not good at drawing are these types that are being flipped. So what we're just trying to picture is that shape being flipped over the x-axis. So it clearly has it's kind of like a V-shaped hole in the middle. Okay, and it's going to be a solid, like I said before, with the hole in the middle, like a sideways bowl almost. Okay, now we're finding the volume of a solid formed by the region, revolving the region bounded by the graphs of x squared plus 1, 0, y equals 0, x equals 0, and x equals 1. So x squared plus 1, and that's our x equals 1. This is 1, 2. So we have this big green shape. We're revolving it around the y-axis. So we could do the washer method for the whole thing. I'm actually going to show you how it's going to be easier to cut this into two. We could do the red box first. That's going to just be the disk method, which is far easier, and the washer with a smaller piece of it. So I think that's what we're going to do. We're going to do the red section first. Now, if we're revolving around the y-axis, we're not looking top to bottom, we're looking left to right. So again, we're looking for our r of x to be the function farther away. So from 0 to 1 on the y-axis, we have the disk method, and it's just 1 squared dy. Then we're going to add on the integral from, let's do the blue one, the integral from 1 to 2, and this is clearly going to be the washer because there's going to be that really big hole in the middle. So if I think about what the top function is, it's not the up and down function, it's the left and right function. So the one that's going to be on top is the one that's farther to the right, and our farther to the right is our x equals 1. That's our capital R, and our little r is the function x squared plus 1, but we need to change x squared plus 1. We need to solve that for x, which would be the square root of y minus 1. Because we are flipping it around the y-axis, it needs to be in terms of y's. Okay, so we have two different sections here. This first one is just the integral of 0 to 1 of 1, and the second one is the integral from 1 to 2 of 1 minus y plus 1, because there's two minuses, which is going to end up being 2 minus y dy. Then we take the integral of each piece of that individually. First one is just y evaluated from 0 to 1. Second one is 2y minus y squared over 2 evaluated from 1 to 2. So if I do all that, I end up getting 3 pi over 2. Okay, so if I think about what that shape is going to look like revolved around the y-axis, the blue half is going to look almost like a bowl with a square base. It's just going to be a really big based cylindrical bowl. So there's going to be a bowl on top, but then the bottom is going to be a really thick cylindrical base. Okay, this is actually the last one we're going to do. We're going to skip the last couple examples in this section. So a manufacturer drills a hole through the center of a metal sphere that has a radius 5 inches. So if we have a radius of 5 inches and it's a sphere, this is the equation of the circle, and the hole has a radius of 3 inches. So here's our function. Solve for y. This is y equals the square root of 25 minus x squared. And this smaller, this is the hole. So this is like we're revolving this red half circle over the x-axis. So it's going to have that hole in the middle with a radius of 3. Okay, so we need to figure out what these integrating limits are. And you would think it would just be negative 5 to 5 because our circle has a radius of 5, but it's not. We need to figure out what y is when x equals 3. So y squared equals 16. Our integrating limits are plus or minus 4. So it's going to be the washer. Clearly, there's going to be that really big hole in the middle. So our top function is the square root of 25 minus x squared, quantity squared, minus our little r, which is 3, quantity squared, whoops, dx. Okay, so if I simplify this before I take the integral, this is 16 minus x squared. I always like to simplify before I take the integral to make it as easy as possible. So pi times 16x minus x cubed over 3, evaluated from negative 4 to 4, times pi on the outside, ends up being 256 over 3 pi inches cubed. And like I mentioned before, we are going to skip the cross sections, and I'm going to tweak your homework assignment just a little bit to make it so we don't have any cross-section questions. We're going to skip number 20, and then just something you're going to need to use for 34 is the fact that cosine squared equals 1 plus cosine 2x over 2. Double angle formula, that will be helpful to you because we can't take the integral of cosine squared. All right, and that is the rest of section 2.